Today we're going to talk about servos and how to test them with your Arduino Uno or Mega, and how we can use them on our model railroad. So let's get started with this right now. I'm Tom Kovichak, and this is Tom's Trains and Things. This is another episode of Arduino Made Easy. Lesson 10, servos, how to operate them on your model railroad and how to figure out what you're going to do with them. So let's get going with this, and let me show you what I'm talking about here with the servos. I have this servo right here sweeping back and forth, and how I did that was on an example. I just modified it a little bit and changed some of the settings on there, and I'll tell you why I changed some of the settings. I'm going to show you a couple of servos here. These are the mini servos. They're 9 gram. Okay, now here they look identical. One is Tower Pro. It's a micro servo SG90. This one here is a Tower Pro SG92R. Now, I don't know exactly what the difference is on it, and I don't even know where I got this 92R from, because all of mine are Tower Pro Micro Servo SG90. Now, I do have some older ones that I got way back. Radio Shack. Let me see. I have another one here. Where's the big one? This one is a standard servo, and you can see that this is much larger. Okay, even though this is a standard servo, it still has the plastic gears in it. So this is a very inexpensive one right here. The more expensive ones are going to have metal gears on them. In this project, we're going to use a wall wart, a 5 volt, 1.5 amp. I'm using 1.5 amp because that's the kind that I got right now, and it's a nice wall wart, and I hooked it up to these connectors right here so I can put them onto the breadboard. We're going to use a SG90 servo, a Arduino Uno, and a breadboard, and some jumper wires there. So that's all we're going to need for this project today. What's inside the servo is a small DC motor that fits inside of there. There's also a small circuit board in there with a chip and a gear reducer. And on the gear reducer, there's a potentiometer that follows and sends back a signal to the Arduino what position we are on here. And I'll show you on the one sketch that I'm going to start you out on how you could determine what your range is on this servo. Now I have this sketch right up here, and it's prompts the user for a value for the servo. I'll show you where you could find it in the examples. Now on your computer it may be in a different place, but mine's way down here on the bottom, and you can see here we go with sweep. It's basically the same sketch. I just modified it slightly to fit what I am showing you here. The ones that I have here are pretty good. I tested all of these, and they're 0 to 180 degrees. Now, when they say 0 to 180 degrees in the specification, that doesn't always mean that they will travel 180 degrees. What we're going to do is include the servo library, and if you have that servo in the example, you're going to have this library here. It normally comes with the Arduino IDE, and the first thing we're going to do is do a position equals 0, and that's just a placeholder for the position we're going to use. We're going to call it servo pin, and we're going to put it on pin number 9. You always want to put your servo on one of the pins that has the little tilde, that little squiggly on there, or on some Unos they have just a dot on there. Those are your PWM pins, and that's how your servo operates with a PWM signal. And servo delay, we're going to put a 25 millisecond delay in there. Now let me show you about the connectors on here. On the connectors, you're always going to have the power on the middle one, and they do it that way just in case you flop this over and hook this up the wrong way. You're not going to be putting your power in the wrong place, so it's always in the middle. This yellow one over here is the signal wire. That's the one that's going on number 9, and this one right here, which looks like it's brown, is going to go on ground. Normally you would have a black wire for ground and a red wire for your power, and whatever it is for your signal wire. So these are probably all manufactured in the same place, but you're going to find some that have different colors on them, and you'll notice that they always have your 5 volt in the center, ground on one side, and then your signal on the other side. So now let's go back to this servo. We're going to call it my pointer. And that's all we have to do up in there. Now let's go down to the void setup. And we're going to turn on the serial monitor. And we're going to do my pointer and attach servo pin. So my pointer is what we called it. I did my pointer and attached the servo pin. So my pointer is right here, and we're attaching this to the servo pin. So that's what this line is right here. Now serial print line, and we're going to ask, where would you like the servo? And why we want to do this is we want to determine the range of the servo, because like I said before, not all servos are 0 to 180 degrees, and you'll be able to tell that if you drive it too far, it's going to sit there and vibrate. You might not be able to see it in the pointer, but if you hold it, you'll be able to feel a slight vibration in it. Now these are pretty good. Some of the older ones that I've seen modelers use, that you could only get maybe from 10 to maybe 170 on it to get a good range without driving it too far. And why it vibrates if you go too far on it, because it's still trying to reach that 180. If you set it at 180, it's still trying to reach that, so it just keeps on bouncing back and forth like that. And it's real small, you might not be able to see it, but if you hold on to it, you'll be able to feel it. We're going to do a while statement, and serial.available equals 0, and that says we're going to wait for the input. So we're going to open up the serial monitor, and we're going to wait for me to put an input in there. Okay, and in position, serial.parseInt. What we want to do is read the user's input, and that's how we do it with this line right here. And we'll go down a little bit further, and we'll say my pointer dot write POS position, and delay, server delay, which was back up at the top. And that's all there is to the loop on here. So basically what we're doing is we're waiting for the user input on here. I have a wall wart. It's 5 volts, 1.5 amp. Oops, I just knocked that off. This is 5 volts and 1.5 amp. Okay, and the reason I have it on there, even though the servo will not damage the Arduino under normal conditions, if you let this thing go too far and sit there, the amperage might go up high enough that you could damage your Arduino and damage your servo. What you want to do is take your power from that wall wart or whatever power supply you have, and you put your power pin on that, and that's the way I have it over here. We're going to hook up the power, which is the center one, directly to power on the wall wart. The ground goes to the ground on the wall wart. It also goes to the ground on the Arduino through this white wire. And the signal pin goes through this blue wire over to pin number 9. And that's where we get the signal to drive this servo. Now, you can drive only one servo off of your Arduino Uno. And that is if you don't overdrive it past the stops and keep it there. The reason I have it on the power supply is to power this individually. And then with that, you could drive more than one servo off of the Arduino. You could run it from the same signal pin or different signal pins running at different speeds or different angles using your external power supply. One of these larger ones, the standard size, do not drive it directly from your Arduino because you'll burn out your Arduino, or it has a timed fuse on there. It will shut it down until it cools back up to where it will run again. But do not use these standard size ones directly to the Arduino. You must have it on an external power supply. Let's go and upload this right now. And it's compiling the sketch. Okay, and it just uploaded and you can see it stopped. What I'm going to do now, you can't see it on here, but let me make this smaller so we can get this over here. There's a little icon right here for a serial monitor. So we're going to open that up. And you can see it says, where would you like the servo? So we're going to start off with bringing it to 90 degrees. And so you can see that's 90 degrees. And I set the arm on there pretty close to straight. It's not always going to get straight. So what we're going to do, you can see it's up here again. We're going to set it to 0 this time. So we'll bring it over to 0. Now on this one, I'm not getting any kind of vibration. So we're good to go on there. And you can see with 90 degrees right here, you would think 0 is right there, but it's a little bit off. These are cheap servos, so they're not exactly precise. So we're going to go to 180 on this one here. And it should be straight across, which is pretty close to straight across. Now I'm not getting any kind of vibration on this one. So we have the full range of 0 to 180 on this one. And whenever we're going to use this on our projects on the model railroad, if you're going to drive your turnout or if you're going to move your crossing gate, there's only a small portion that you're going to use out of that 180 degrees, and you may only have, like, say, let me see where 85 puts this, say from there to, let's say 95. Well, it might be a little bit longer than that. Maybe let's do 75. Okay, 75 is right there, and we'll go to 110. So that's about the range that we're going to need for a turnout. Now for the crossing gate, you're probably even going to use a little bit less than that. But this is the way that you want to determine how far it is. You want to use this sketch right here and hook this up to either your turnout or your crossing gate to actually find where the sweet spot is to operate your devices. There. So we're going to go back to that other sketch. This is the other sketch where I ran it from 5 to 180. So we're going to, and this is basically the same thing. The top part of it's the same. Serial begin. We really don't need the serial monitor on this one. My pointer attached servo pin, and that's all. That is the same right there. So we'll bring this down, and what we want to do is we want to put in a for loop. So we're going to put position 5 and position 180, and what I'll do is I'll just change this over to 0, because on this particular servo right here, we have the full 180 degrees of it, and I'm going to show you that we can go back and forth on that. So we'll go position, okay, for position equals 0, then the semicolon, and the position less than or equal to 180, and then we're going to step through it, position equal position plus 1. Okay, and then my pointer dot right, and we're going to write the position on my pointer, and then we're going to delay it, servo delay, by the 25 milliseconds that we have up on the top here. And you see the 25 milliseconds up there, and we could increase that to make it go slower. Now, and what we want to do, that'll drive it in one direction. So to drive it in the opposite direction, we're going to go the opposite way, 4, and we'll start off with position equal 180, and then 2, position greater than or equal to 5, we'll put it at 0. And then position equal position minus 1. And then we write to the position, and then we delay it. So we'll come up here and we'll upload it and see what happens. Wait for it to upload, and you'll see that it'll go back and forth. Now let's say that we want to do what we talked about before, and we'll go from, let me see, we'll go from 75 maybe to 105, and then we'll do the same thing on the bottom line, and that'll just give us a small rotation. Okay, so you see how far this goes right here. It uses the full travel of your device. Now we'll reduce it down to 75 to 105. And it's uploading. Okay, now you can see it's going back and forth that much. Okay, so if you just wanted to use your turnout, you use this for one direction and put your button in there, or put your switch in there, and then use this part of it to go the opposite direction. You put your switch or your button in there, however you want to operate your turnout. The same thing with your crossing gate. Now with the crossing gate, we're a little bit more complex on that one, because we're also using the flashers on that. And what I'll do is I'll do another video on this. I won't put it in the Arduino Made Easy. I'll put it in the Arduino projects. Say you want to slow that down. So you see I only have that set for 25 milliseconds. Let's go to 100 milliseconds, and we'll upload that, and we'll see what happens there. Okay, it's uploading. So it goes a little bit slower. So that's how you can control the speed of it. You change that servo delay, you give it a longer time, and that will go slower. And what this is doing is that +1 and -1, it's taken 1 degree at a time, and has that right now, the 100 milliseconds, it's delaying 100 milliseconds between each step. So it's going those 30, from 75 to 105 degrees, and it's taking 100 milliseconds in between each one of the steps. Now if we change the position to 2, we'll go one direction 2, and the other direction we'll leave it at 1. So it'll go twice as fast in one direction as it does in the other direction. So it's uploading now. So you can see This way it goes a little bit faster, and then it goes this way here. In a future episode, I'm going to show you how we're going to take this and use it for our turnout. I have to bring this up a little bit. We'll use this for our turnout and for our crossing gate. This is the only standard servo I have. I'm going to have to get some more one, but I want to get some with the metal gearing inside of it, because the plastic ones are really cheap. Now, I'm also going to tell you, do not try to turn the gearing in here. This is a gear motor, so you have a series of gears. I don't know if you could see it in one of these. I think there's 3 gears. 1, 2, 3, 4 gears in there. So it's a gearbox. If you try to move this arm without any power on it, you could have the possibility of either stripping out the gears on here or stripping the little splines on the shaft. This is just plastic, so if you try to turn this, you're going to damage something on there. But anyway, that's what we have for right now. So we got the other ones coming up, and we're going to do some more projects on Arduino. I know I took a break in it for a while. We had a lot of things going on, but we're going to get back into these projects right now. So until the next time, we'll see ya.